Welcome, AP physicists. We're looking at section 2.3. This is on analysis models. If you'd like to follow along in your books, you can. Basically, we're going to look at the ability to find that many problems can be grouped into categories and solved with then similar strategies. So an analysis model is essentially just identifying a fundamental problem, recognizing that if it fits some basic principles, that it can be applied to many other problems that end up being similar in style or in the physical concepts that back that problem. So for example, many problems could be modeled as a particle under a constant velocity. Lots of problems could be modeled in this way. There could be different objects that you're looking at, various situations, but if you know that the thing is moving with a constant velocity, it gives you a way to better understand that problem and know how to attack it in terms of your problem solving. So if you're looking at a problem that had a constant velocity, what would that then indicate or mean about your instantaneous velocity as opposed to your average velocity? If you think back, you would remember that in the case of a constant velocity, your instantaneous velocity is equal to your average velocity at all times because the velocity is constant. It's never changing. So what kind of motion is considered a constant velocity? Think back to regular physics. And remember that velocity is both a direction and a speed. So if you're talking about a constant velocity, you're really talking about something that has maintained its direction or is moving in a straight line and is maintaining its speed. So what if your path was actually circular or curved? In that case, we would not be able to talk about a constant velocity because constant velocity maintains its direction. However, you could talk about a constant speed. So if you're moving in a circle at 5 meters per second that had a radius of 10 meters, we could again look at the idea of velocity as being a displacement over time. But in the case of moving in a circle, we'd really want to be looking at the speed of this object. And rather than having this be a displacement over some time interval, we're really looking at this now becoming a distance over some time. Because your speed could certainly be constant as you move in that circular path, although your velocity would not since you're changing directions. So if we need to know a total distance as you move around this circle, you can clearly see that moving around that circle one time would be considered the circumference of that circle, where that distance could be found with a 2 pi r. Putting this into our equation then for speed, our displacement is 2 pi times the radius of 10 over some time interval, and that speed should be equal to 5 meters per second. I'll give you a chance to work this out on your calculators. If you'd like to pause the video right now and see if you can come up with the answer, go ahead and do that. When you plug all those numbers in, you'd find that that time interval is about 12.6 seconds. Let's look at another problem that also is utilizing a velocity. Let's say that a physicist wants to maintain a constant velocity and time himself as he's moving through a 20-meter displacement. Now, as he moves through this displacement, he realizes that if he were to time himself, it's taking him about 4.4 seconds to complete this displacement. So the question is, what is his average velocity? Well, again, a velocity is going to be a displacement over a time interval for that average or constant velocity in this case. We know that his displacement that he's going through was a 20-meter displacement. And the stopwatch indicated that that took him about 4.4 seconds to complete that. So again, if you plug that into your calculators, you'd find that this average velocity for this physicist is about 4.5 meters per second. We could look at other questions that are associated with this problem, such as where would the runner be after 10 seconds worth of time? Well, now that we know that his average, or in this case constant velocity, is 4.5 meters per second, that should be equal to whatever displacement he covers over the 10-second time interval. Again, putting this into your calculators, you would find that that displacement after 10 seconds would now be about 45 meters. So the idea here is that this is one type of analysis model, a constant velocity problem. But there's a lot of problems that we'll look at in physics. Some of them will fit this type of model, and we'll be applying the same types of equations in the same ways, and others will fit other types of models that we'll look at. In fact, in the next section, we'll look at some constant acceleration problems and see what types of equations and thought processes you use for those types of problems.